Welcome to the Statistics and Analytics series. This is the first class, Foundation of Probability. Quick words on what this series is, so you know what to expect. Every class here takes one concept from statistics or analytics and explain it the way it is actually used in business, with real situations from e-commerce, food delivery, streaming apps, payments, and product teams. Not exam preparation, not heavy maths. Just the concept, why it matters, and how it turned into a business decision. Today's class covers the foundation everything else stands on probability. What it is, how to read it, and how professionals use it to make decisions every single day. By the end of this class, when someone shows you a number like 72% chance of churn, you will know exactly what that number is saying and what questions to ask before trusting it. No prior knowledge needed. If you can follow a business conversation, you can follow this class. Let us start. Think about what happens every day inside the apps on your phone. A payment app blocks a transaction before any human has checked it. A food delivery app tells you your order will arrive in 32 minutes before the restaurant has even started cooking. A streaming app decides which shows to put on your home screen. Out of thousands, a product team launches a new feature because a test said it worked. None of these decisions are certain, but they still happen every day at massive scale with full confidence. What makes this possible? Probability. So, what is probability? In the simplest word, it is how we put a number on uncertainty. We talk about uncertainty all the time. The customer will probably leave us. There is a small chance this campaign fails. The launch will almost surely get delayed. Now, the problem with these lines is not what they are wrong. The problem is my probably and your probably can mean two very different things. Maybe I mean 60%, maybe you mean 90%. We will never know. Probability fixes this. It replaces the bad word with a number. And that number means the same things to everyone, in every team, in every company, and in every country. That is what this class is about, turning gut feelings into a number. And it matters because everything later in this series is built on top of it. Sampling, hypothesis testing, machine learning, open any of them, and you will find today's idea sitting inside. One more reason to pay attention. Every number in a dashboard that predicts something, a risk score, a churn score, a forecast, is really a probability with a business name on it. If you understand what is under that number, you know what to ask when someone show it to you. And how was this calculated? On what data? And how much should I trust it? If you do not understand it, you have only two options: trust it blindly or ignore it blindly. But both are bad practices. Before any formula, let us see where probability actually does its jobs in a business. Four places. Together, they cover most of analytics. First one is statistical inference. Working with samples, almost nothing in business is measured on everyone. You survey 1000 customers, not all of them. You test a future on 5% of users, not all of them. The moment you work with a sample, there is a gap between what you measured and what is actually true. Probability tells you how big that gap can be. The second one is A B testing. Every test comes down to one question: is this difference real, or is it just luck that looks like a result? An e commerce team changing a checkout button, a delivery app, changing its home screen. If you answer this by feeling, you will end up launching changes that did nothing or killing changes that would have worked. Third one is risk management. In banking and in insurance, probability is the difference between this will risky and this has 3% chance of default. The second one, you can put a price on. You can plan for it. The first one is just an opinion. Fourth one is machine learning models. Machine learning models like churn models, recommendation engines, delivery time predictions, remove the fancy names, and most of it is a machine that produce probabilities. When a streaming app recommends a show, it is really saying, out of everything we have, this one has the highest chance that you will press play. Now let me show you the common thread with one small story. This is the part that matters most. A product team tests a new onboarding flow. Old flow, for example, you just think like old flow showing 34% of users activate and new flow is 38%. The instant reaction, new flow wins, launch it. But wait, think about flipping a normal coin 100 times. You will not get exactly 50 heads every time. Sometimes 46, sometimes 53. The coin did not change. That is just randomness. The small things happen with users. Even if the new flow made zero difference, the two groups would still show some gap, simply because of which users happen to fall into which group. So the real question was never is 38 bigger than 34. The real question is a 4 point gap bigger than what pure luck would normally create here? If luck alone easily create a gap of 5 or 6 points with this many users, then this results means nothing. If luck rarely creates a gap of more than 1 or 2 points, then this results means a lot. That one move, comparing what you saw against what luck alone would create, is the seed of everything hypothesis testing does later in this series. Today we are only learning the language for it. But notice what this move needs. A way to put a number on what luck would normally create. That number is a probability. Without it, there is no science, only opinions with charts. So, what does this number look like? Every probability sits between 0 and 1. That is a full range. Nothing below 0, nothing above 1. And every daily statement about chance fits somewhere on it. It will probably rain. Becomes probability of rain is 0.80. This order will probably arrive on time. Becomes probability of on time delivery is 0.91. The customer is very likely to churn. Becomes probability of churn is 0.72. Now look carefully at the last one. Very likely to churn, that is a feeling. Probability of churn is 0.72. That is a claim. A clear claim. Out of customers who look like this one, about 7 out of 10 left us in the past. A feeling cannot be checked, but a claim can. And that is exactly its power. You can test it against reality, compare it with another model, and build a rule on top of it. Take action above 0.65, do nothing below. You cannot build a rule on very likely, but you can build one on 0.72. The same number can be written in three different ways. One is fraction, another one is decimal, and another one is percentage. Same thing, three different formats. It sounds like a small point, but there is a real skill here.
Different rooms expect different format. For example, a risk team reads percentages. A modeling team works in decimals. Use the one your audience reads fastest. Small thing, but this is the difference between communicating and simply remote reporting. One more thing about 0 to 1 scale. It is a universal. A coin flip, a card draw, a churn model, a credit decision. All of them sits on the same line. That is why Max created centuries ago for gambling works perfectly today for customer behavior and loans. Same scale, same rules, different stakes. So, three values on this scale need special attention. Each one has an exact meaning, and each one also works as a quick health check for real models. First, probability equal to zero. This means impossible, not rare, not almost never. Impossible, the outcome simply cannot happen. The classic example, rolling a 9 on a normal dice. So there is no 9 on the dice. Roll it over forever, it will not come. The business version, a user writing a product review for an item they never ordered on a platform where reviews are only allowed after delivery. That is a zero. Not because it is rare, because the system does not allow it. Why does this matter in real work? Because if a live model ever gives exactly zero for something that actually can happen, that is not a prediction. That is a bug. The model has decided something is impossible when it is not. Usually, the reason is a data problem. Some category the training data never saw, or a broken pipeline. Knowing that zero means impossible, not very likely, is what help you catch that bug instead of walking past it. Second, probability equal to 1. This means certain, guaranteed. Every time, no exception. A visitor on a web page either leaves or stays. There is no third option. So the probability of leaves or stays is exactly 1. Sounds obvious. But hiding inside this is the most useful checks in all probability. Across all possible outcomes of a situation, the probabilities must be added up to exactly 1. Every possibility counted, nothing counted twice. So when you review a model and the outcome probabilities add up to zero point 0.9 or 1.2, something is broken. Find it before you trust anything built on top. Third, probability is equal to zero point 0.5. This is the point of maximum uncertainty. A pure 50-50 equally likely to happen or not. And in analytics, this value tells you something specific and a little uncomfortable. A model that predicts zero point 0.5 for a case is telling you that it knows nothing about that case. No signal either way. A model that is actually learning moves its prediction away from zero point 0.5 towards 0 or towards 1 as it finds pattern. So if you see a model when most predictions sit near zero point 0.5, that is a finding, not a small detail. Either the problem really is a coin flip, which is rare in business, or the model has not found any signal yet and needs better inputs or more data. There is a sharper version of this idea because it comes in serious model reviews. Calibration. A well calibrated model is one where these numbers means what they say. Out of all customers, it scores at 70% churn. Around 70% should actually churn, not 90, not 40. And here is the interesting part. This is different from accuracy. A model can rank customers correctly, most likely to leave at the top, least likely at the bottom. While the actual number it prints are wrong, That model is fine for deciding who to call first. It is dangerous for financial planning. Knowing this difference, there is a difference between reading a model's output and actually judging it. Reading probabilities above and below 50%. Everything below zero point 0.5 leads towards will not happen. Everything above leans towards will happen. But direction is only half the reading. The other half is distance. How far from zero point 0.5 the number sits. Getting a feel for distance is what makes probability useful in a meeting, not just correct on paper. Let us walk down the low side. 25%. Rolling a 1 or 2 on a dice. Unlikely, but honestly quite common. It happens one time in 4. Seeing it once tells you nothing. 8% pulling one specific card ran from a full deck. Now it is uncommon. Seeing it once in worth noticing. 2% a fraud model flagging a transaction. This is a different category. Rare and serious because of what it represents. And here is a trap worth calling out. Because even experienced people fall into it. Rare is not the same as small. 2% sounds tiny until it meets volume. A payment platform handling 10 lakh transactions a day. Flagging 2% is creating 20,000 flags a day. Every one of them needs some kind of review. The probability tells you the chance per transaction. It tells you nothing about the total workload until you multiply by the volume. Skipping that multiplication is one of the most common ways probability get misread in business. It is also why rare but costly events like fraud, defaults, system failures get so much attention despite being rare. Missing one costs far more than checking many false alarms. Now, the high side, where number starts triggering action. A returning customer with a 72% chance of buying again within 30 days. Strong enough to send a loyalty offer. An 85% chance of rain. Strong enough for the app to send you an alert. A ride hailing app seeing a 95% chance of high demand in an area. Strong enough to move drivers there before the rush even starts. But notice something in these three examples. Each one quietly contains a threshold, a line above which the number becomes a decision. And that line is not max, it is a business judgment about the cost of being wrong. A marketing team can act at 60% because a wrong guess costs one slightly useless email. A lending team needs a much higher bar because a wrong guess is an approved loan that defaults, costly and hard to undo. Same type of number, completely different bar. Setting that bar deliberately based on what a mistake cost instead of picking a round number by habit. That is one of the first truly senior judgment calls in this field. And it is available to you from the day one of understanding probability. So, three things to take from this class. One, probability replaces a vague word with a claim you can check. Very likely is a feeling. 0.72 is a statement about the world. You can test it, compare it, act on it. That is the entire reason it runs modern analytics. Two, the anchor points are not textbook trivia. They are health checks. Zero means impossible. A model saying zero about a possible event is broken. One means certain outcomes that do not add up to, one means something is wrong. And 0.5 means the model knows nothing. Prediction sitting, there are questions to raise, not a detail to skip. Third one is reading a probability means reading three things together. How far from 0.5 multiplied by what volume against what cost of being wrong? That is the difference between reporting a number and interpreting one. And interpreting is the job. Next class, the working parts. The probability formula, sample space, and notation, where probability stops being an idea and becomes something you can calculate yourself from scratch on anything.